Greetings and welcome, friends. Today we are not leaving the world of logic, but we are reveling, basking in the joys of geometry. And we're going to just believe things because I told you to today. Because that's what postulates are. We accept them as true, and I don't think that these are incredulous by any means. I think that you'll probably believe them, and in some cases be like, did we even really need to write that down? Was this worth the ink on paper to make that claim? And as far as like the building blocks of geometry, yes, we did need to write it down so we'd all have an agreed upon basis to build from. But here we go. It says point, line, and plane postulates. Here you go. These ones are not like these. This is like the guy that was way too shy to ask the girl out, and like he built up the courage to say hi, and that's as far as he thought it out and did. Ready? Like, look how bold this is. 2-point postulate. Through any 2 points, there exists exactly one line. Okay, and now here you go. This one's even bolder. A line contains at least 2 points. Like, I don't know if I can even go to 4, but we'll agree that there's at least 2, right? So, does anyone doubt that? I hope not, right? There's at least 2 points on a line. So yeah, like I said, not a really bold claim, something I think we'll all accept as true. And if 2 lines intersect, then their intersection is exactly 1 point. As if these 2 lines are distinct. I might kind of just emphasize that, right? They are not the same line. If 2 lines are the same line, then they're intersecting all over the place. And I would say that they would at least have 2 points in common. But we'll know that there's a lot more than that. So yeah, the intersection of 2 lines is at exactly 1 point, right? And then, let's go to 3 dimensions. 3-point postulate. Through any 3 non-collinear points, there exists exactly 1 plane. All right, so 3 points. There's a plane that all of those exist on. The plane point postulate. A plane contains at least 3 non-collinear points. You guys would probably say that there's like 5 though, right? Like I'm sure, right? You probably believe that. But let's not be so brazen. Let's just say at least 3. At least 3. Plane line postulate. If 2 points lie in a plane, then the line containing them lies in the plane. So if there's 2 points in a plane, and since I can then draw a line through those 2 points, this is now saying that that entire line, its entire existence, will be on that plane, the same plane as those 2 points. Right? Yeah? And then the plane intersection postulate. If 2 planes intersect, then their intersection is a line. Yeah? You could have 2 planes being the same plane, and then they're intersecting. But yeah, those planes continue on infinitely, so yep. But yeah, so these are some postulates. We believe them because they're true, and I'm not going to prove them to you. And let's see if we can identify these. I've got to familiarize myself with these as well. Let's see. State the postulate illustrated by the diagram. So if 2 lines intersect, then their intersection is a point. Was that was the name of it? Line intersection postulate. Okay. If 2 planes intersect, then that intersection is a line. I'm guessing. All right, so that's, I mean, it's just a matter of like, you have to, right, match it to the thing. But yeah, knowing all of these names takes a little bit of time and becoming familiar with them. Oh, he'll be able to catch it online. Hey, Ryan, I know you're watching this later. We all said hi. Yeah. So here we go. It says, use the diagram to write examples of the plane point postulate. All right, so the plane point postulate. All right. Plane, point, line. It basically, like, this just, like, had a couple of dice that had the words point, line, plane, postulate, intersection, and then they just rolled them and made all of these names randomly. So let's see, I already forgot which one I'm looking for. Plane, point, postulate, which says a plane contains at least 3 non-collinear points. Does anyone see 3 non-collinear points on one of these planes? Yeah, so A, B, and C on plane. Looks like that plane is a plane P. All right. The lowercase n is the line. Plane P is on plane P. There we go. And how about the plane line postulate? That's the one with like 2 points, then the line is entirely on the plane. Is that right? So I would say line AB is on plane P. Yeah? Based on what I'm looking at there. What about the plane intersection postulate if I add that one? The intersection of planes P and Q is line M, right? So, yeah. I mean, these are just, takes a little practice getting used to muchos nombres. Ooh, I think I liked this one. This is example 7 on page 74 of our blue geometry book. I think I put this in there. Right, look at even like this. Look at this old school like this detail was supposed to be enough to like excite you about geometry. It's like, look at this thing's not even a rectangle. It's like got rounded edges. And you're like, man, geometry is so imaginative. Right? So it says decide whether the statement is true or false. If it is false, give a counterexample. A line can be in more than one plane. Well, what's the intersection of 2 planes? A line, so this is true. Actually, it can exist if I have a line. You could imagine there being infinitely many planes that line passes through. Right, so there's another plane, and right, so you could imagine just like rotating planes around that line. There's infinitely many of them. Infinity. Or actually, let's just say there's more than one, because it's a postulate kind of day. I don't want to overcommit, right? I don't want to put my heart out there and just like have it be broken. So I'll just say there's more than one plane. 4 non-collinear points are always coplanar. False, I'm hearing. I'm going to just draw a box and imagine these 1, 2, 3. Those exist on a common plane, and they're non-collinear to each other. But then the moment I add a 4th point, say over here, right, they're not coplanar. I could imagine a plane that passes through these 3. Right? Like I could imagine that, but I'm never going to be able to draw a plane that hits all 4. So that's false. Not always. It's possible, like if I picked the corner, right, this corner here, then that would have worked. 2 non-intersecting lines can be non-coplanar. Whoa. Let me draw a box again. What do you guys think? How are you feeling about this? So non-intersecting, if they were coplanar, would have been what types of lines? 2 lines in a single plane. Yeah, parallel. So here's a line. Is it possible to have what does non-coplanar, non-intersecting lines look like? All right, those lines will never cross each other, and they also don't exist on the same plane. These are called skew lines, by the way. Skew. That's skewal. No, sorry. I regret that already. But if you guys want to, like, in your, underground speak, like, make some awesome new lingo, you could say that's skewel when, like, something is cool. I don't know. You don't have to, though, but it would make my day. It's fine. Let's see, how about, can we sketch this? Sketch a diagram showing a line TV intersecting PQ at point W so that T to W is congruent to V to W. So let me draw. All right, so here's a segment PQ. There's like infinitely many ways you could draw this. And then point W is somewhere on this. And now it doesn't have to be the midpoint of PQ, but W does need to be the midpoint of TV, right? The segment. You can't have a midpoint of an infinite line. So I'm going to draw like this, just randomly. And so I'd have a line, and T has to be the same distance from W as V, right? So I can have, this is congruent to that. Right, so there's a whole bunch of different ways you could have started drawing that, but that's what it looks like. See, my mouse is a little bit, like, lagging today. I need some new bat trays. It's okay. All right, how about this? A line is a line perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line at that point that is on the plane, right? So you can imagine perpendicularness, right? So there'd be like a whole bunch of other lines that intersected, but it's going to be perpendicular to all of them, right? It's the one line that rose above the others on the plane and just like ascended above them. It's amazing. That is the line right there. And let's see. Yeah, it's going to be marked, shown with a right angle. And actually, notice that my right angle box looks more like little parallelogram rhombuses when they're kind of three-dimensionally represented. Let's see, can we interpret a diagram? We were doing some of this in our exploration warm-up. Example 4. I'm just glad I can teach this so much faster now that you guys aren't spending like 10 minutes to draw a picture, right? Like, that would have been just, there you go. Right. Yeah, and then that's why, like, I was like, man, I've got to start doing something about that, because they're like, Mr. Waddy, slow down. And I'm like, no, I'm the Flash. And I didn't. And then they just were splattered in the face of mathematics. Alas. But anyways, example 4, interpreting a diagram. Which of the following statements cannot be assumed from the diagram? I might just go with the true falseness of it. Points A, B, and F are collinear. I was just trying to imagine a person named Colin and what situation you would say collinear. Like if you had two Collins, and you're like, listen, Colin Dubs, you are just not as good as Colin T. Colin T is just collinear than you. But then, like, you hire, like, new Colin G, and he is just the Colliniest of all of them. He would be the best Colin, and everyone would know it. But yeah, Colin Dubs, Colin W, you just feel bad for the guy. He's the Colin East. I don't know. Let's see, points A, B, and F. Are those collinear? A, B, F. That's true, so that can be assumed from the diagram, which means it cannot be assumed. I'm just calling it true. Points E, B, and D. So here's E, here's B, and D. Those are all on a same plane. You might imagine a line that those could pass through or exist on, but that cannot be assumed. So this one is not assumable. Let's see, AB is perpendicular to plane S. So here's AB. Is that perpendicular to the plane S here. They've got this little perpendicular thing, and notice it's actually not connected to a ray or a segment or a line. So I think they are indicating perpendicularity with that. Yeah, so that's a true. Is CD perpendicular to plane T? So here we go. That looks like some sort of acute and obtuse angles there. And it's not labeled. So even if it looked perpendicular, I cannot make such an assumption. So that is false, and therefore this one is cannot assumable either. AF intersects BC at point B. Let's see, AF and BC at point B. That's true. That's true, friends. Believe it or not, I'm walking on air. Hey, oh, we're done. All right. I was like all ready to keep going, internet friends, and then it's all done. All right. Well, if you are the Colliniest Colin, make sure you comment in the comments below. Thanks for watching. Bye-bye.